So for section 3, we're going to do box and whisker plots. How many of you remember doing box and whisker plots back in like junior high? Any of you? Some of you, not very many though. Okay. So that's good for me to know that we don't maybe remember quite as, or have not seen quite as much as some of the previous years. But we're going to find a box and whisker plot, which is essentially a way of showing how the data is spread out using what are called quartiles, splitting the data into fourths, right? Quarter, quartile. So let's take a look at this. We're going to find what's called a 5-number summary. The 5-number summary is the basis of a box and whisker plot. And the 5-number summary splits our data set into 4 parts, right? If I have 5 numbers, in between those numbers, I have 4 sections. Does that make sense? 1, 2, 3, 4 sections from 5 numbers. So here is going to be our 5-number summary, and it's always the same. You're going to have a minimum, which is the smallest value. You're going to have a maximum or a high or highest value. And then you're going to have the median, which is the middle number. Does everybody get the idea that in order for this to work, the data has to be in order? Does that make sense? A box and whisker 5-number summary does nothing, means nothing, if the numbers are not in order. So looking at this first data set, they've already put the numbers in order for us. Sometimes, you guys, this is the hardest part, is putting the numbers in order. You don't want to skip any, you don't want to count any of them twice. You need to make sure they're in order. So now looking at this, once they're in order, it's real easy to find the minimum and maximum, or minimum and high. So this one would be the minimum. This one would be high or max. You can use either word. I should use high because that's what's over there. So our minimum in this case is 0. Our highest number is 9. The median is the middle number, literally the one that's right in the middle. So if I have 1, 2, 3, 4, 5, 6, 7 numbers, I can kind of count in 1, 2, 3, 4, 1, 2, 3, 4. This number right here is in the middle. So that is my median. Now the median itself, here's where we start to have issues if we're not paying attention. So again, phones away, earbuds out. The median now is separate. It's not in the lower half or the upper half. We don't count the median for the next part. Quartile 1 is the median of the lower half. So the median of these numbers, not including the median of the whole set. So this 2 is quartile 1 because it's the middle number for the lower set. This up here, 6, is quartile 3 because it's the middle of the upper set. So at this point, I have everything I need to make a box and whisker plot. Yes. A little louder. Why is it quartile 3? Because the median would be quartile 2. Does that make sense? You'd have the beginning, quartile 1, quartile 2, quartile 3, quartile 4, the top of each of those quartiles. So to make a box and whisker plot, then we need kind of a way of measuring stuff because we want stuff to be spaced appropriately. So my numbers go from 0 to 9. So I'm going to do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Do 10 as well if you want to. So here's 0 to 10. And then we put a dot at each of those points. So I have a dot at 0, that's my minimum. I have a dot at 2, that's my quartile 1. A dot at 5, that's my median. A dot at 6, That's quartile 3, and a dot at 9. That's my high value. Does that make sense to everybody? So far, so good? Now you draw a box around the middle 3. Here's the box part of my box and whisker. Draw a line through the middle one. And then the whiskers go from the box out to the high and down to the minimum. Yes. What was that? The 4 doesn't show up. It's inside the box. No matter how many numbers I have in my data set, I'm only going to use 5 of them to make the box and whisker plot. The others are going to be inside the different pieces of that box and whisker plot. So yes, the 4 is inside here. The 6 happened to be on a dot because there were 2 6s. If there were more numbers, there would be less that are represented by dots here, because I'd still only have 5 dots. Does that make sense? So now, oops, try that again. There we go. So look at number 2. Same exact thing. Are the numbers in order? Yes. That's the first thing I need to check. I need to make sure they're in order. Now, the smallest one is my minimum. Biggest one is your maximum or high value. The middle, 1, 2, 3, 4, 5, 6, 7, 8. Oh, if I have 8, there is not a middle number. Does that make sense to everybody? 4 and 4, there's no number in the middle. When that happens, I go to the middle 2. And I say, okay, what's my average of those 2? So 14 plus 15 divided by 2 is 14.5. 14.5. That number is my median. Now, because there was no middle number, that 14.5 does not go with the lower or higher set, but the 14 is going to go with the lower, and the 15 is going to go with the higher for finding quartile 1 and quartile 3. So now I have to do the same thing because the bottom set has 4. There's no middle number there either. So I need to take the average of these 2. 12 plus 13 divided by 2 is going to be 12.5. 12.5 is going to be my quartile 1. And then up here, 15 plus 17 divided by 2 is going to be 16. That's going to be my quartile 3. This will happen about half the time, where you'll have to average 2 numbers to get the actual middle value. So now I have my minimum, quartile 1, median, quartile 3, maximum. I can draw in my box and whisker plot. So it looks like we're going from 10 to 18. So we're doing 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So my minimum was at 10. My median was 14.5, so that's halfway in between. My maximum was at 18. Quartile 1 was at 12.5. Quartile 3 was at 16. Does everybody understand where these numbers are coming from? Now, box goes around the middle 3. So quartile 1 to quartile 3, there's my box. Line through that median and whiskers out to the minimum and maximum. Now, why are we doing this? What does the box and whisker represent? This whisker represents the lowest 25%. Each whisker represents a 25%, and each half of the box represents 25%. So there's 25%, here's 25%, here's 25%, here's 25%. So inside the box is half my data. My middle half is in the box. The lowest quarter is in the bottom whisker. The highest quarter is in the top whisker. So it's a way of representing how my data is grouped. It's a way of representing how my data is grouped. Does that make sense to everybody? That is something that used to be taught in junior high a whole lot. So some of you may have seen that before. The new piece, now for some of you that's new, that's fine. Hopefully it's making sense. If not, please ask. The part that's supposed to be new is what we're going to modify this box and whisker plot, because sometimes you have values that are very different than the others. Do you have a question? Go for it. Because since the bottom had 4 numbers, there was still no middle. And so I had to average them. Anytime you have an even data set and you need a median, you go to the middle 2 numbers and average them. Does that make sense? What was your question? So the idea is all my data would be 100% of the data. Does that make sense? The reason we do box and whisker plots is to divide it up into quarters so that we can say, okay, the middle 50% is inside the box. And so this will help us see, like, okay, is all the data kind of right in the middle? Is it really spread out? Is there a few that are really high, but then everything else is kind of clustered together lower? It helps group our data to give us an idea of where the numbers actually are. How is it distributed? So now here's the hard part of today's lesson. I put it in quotes because it's not hard, but it takes a little bit of work. It's, again, a little formula, easier than the formula for yesterday. We're going to add in a specific way of finding what's called an outlier. An outlier is a value that is very different than everything else. So, for example, in my typical Math 3 classes, I have a bunch of students who are all between the ages of 15 and 18. Does that make sense? If I average their ages, the average would be like 17, something like that. If we add my age into the average of the class, I can raise the entire average of the class by about 1 year. Does that make sense? Depending. I am an outlier in this class. My data messes everything up. Does that make sense to everybody? It's different enough that it causes all the other data, the mean, the median, well, not the median, but the mean, the quartiles, all of that stuff gets messed up if I'm included. And so we want to have a way of identifying those. We want to be able to note that number right there is different enough that I shouldn't use it. Does that make sense? So that's what we're going to call an outlier. And we want it to be objective, not subjective. We don't just want to look and say, that one looks too big, or that one looks too small. We want to have an actual boundary and say anything past this is too big or too different. That's what I'm going to show you right here. So again, outlier is a value that doesn't follow the pattern of the other data values. To figure out if you have an outlier, you calculate 2 boundaries. Okay, everyone, full attention. The boundaries are not a part of your box and whisker plot. They don't show up on your graph unless you want to add them in, but they're not a data point. They're just a way of showing anything outside of this is an outlier. So the upper boundary and the lower boundary require you to find what's called the interquartile range. The interquartile range is literally the width of the box. The width of the box. So you find your box and whisker plot. The box, how wide is it? What's the distance between quartile 3 and quartile 1. That's the width of your box. And it shows it right here. IQR is Q3 minus Q1. Now, we want a little bit more than that. So we always multiply the IQR by 1.5. We say, okay, here's how big my box is. I can take that and half again that much. That's my acceptable range, is the IQR times 1.5. It's always times 1.5. That doesn't change. That's the value that we've picked. To say anything beyond this is too much. So for the upper boundary, we add that to Q3. So here's my box. I go 1.5 IQRs above it. And then from Q1, I subtract it 1.5 IQRs below that. That now is my lower and upper boundary. Anything outside of that is an outlier. So let's try it. Oh, and real quick, if it's on the boundary, it's not an outlier. On the boundary is okay. It has to be past the boundary. And then if you have those, you use an X to mark the outlier. It does not get used then on the main box and whisker plot. It's just an X showing that there was a data value that we took out. And then your box and whisker plot extends to the next highest or lowest value. So let's try it here. Make a box and whisker plot for each set of data, check for outliers. This is on the next page. The first thing you should do is check, is the data in order? 20, 22, 22, 24, 26, 29, 29, 33, 55. Perfect. It's in order. So now I'm going to go through here and I'm going to find the lowest number. So here's my minimum or low. Here's my maximum or high. So those are my ends. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 terms. That's odd. I'm going to have a middle number. My middle number, my median, is 26. Does that make sense to everybody? That's my middle number. But now when I look at the bottom set, oh, I don't have a middle number there. So I have to take an average. 22 and 22, well, that's convenient. My Q1 is 22. Up here, oh, right in between there, 29 and 33. Take an average of those, it should be 31, right? 31 is my Q3. Why is it not going to let me make a 3? There we go. Now, does everyone see why I didn't use the 26? Everybody see why the 26 is not used? That's the median. I don't use the median in the lower set or the upper set. Yes. Right, you add them together and divide by 2. You take their average. Does that make sense to everybody? Now the IQR. The IQR is the Q3 minus Q1. Q3 minus Q1, 31 minus 22. 31 minus 22 is 9. That's the width of my box. That's how wide my box is going to be. Now I need to multiply that by 1.5. Always times 1.5. 9 times 1.5 is 13.5. Does everyone see that this is based off of the box? That's my width. Now I'm going to go below the box by that amount. So I'm going to take this value, 22, and I'm going to do 22 minus 9, or sorry, minus 13.5. 22 minus 13.5 gets me 8.5. That's my lower boundary. Lower boundary is 8.5. Upper boundary, I'm going to take my Q3, 31. And I'm going to add 13.5, which gets me 44.5. That's my upper boundary. Do I have any numbers? Yes, Aaron. Remember, it is always 1.5. That's the instructions. You multiply by 1.5 every time. It's not going to change. That's the number that's been chosen to say anything past this is too much. So LB is the lower boundary. UB is the upper boundary. Do I have any numbers that are below the lower boundary or above the upper boundary? Which one? Does everybody see that 55 is above the upper boundary? So now when I graph this, I'm going to label these. I need to go from 20 to 55. So let's see here. Can I do 20? Can I do 5s 20, 25, 30, 35, 40, 45, 50, 55? That should work. So let's actually, I'm going to start down here at 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So label the bottom axis so that you're consistent. My low value was 20. I'm going to put it right here. My Q1 was 22, so that would be kind of a little bit less than halfway to 25. My median was 26, so a little bit past 25. And here I'll label these. This is the L, low boundary, or sorry, low value. This was Q1. This is the median. Q3 was 31, so that'd be right here. Here's Q3. And then normally, my high value would have been up here at 55. Do you all see that that is very different than the other data values now? So instead of putting that point, I'm actually going to X it out. I'm going to put an X here. What's my next highest value? 33. That's going to be my high value. Well, that's going to be the end of my whisker. The 55 is still technically my high value in my 5-number summary. But I cut it off for the box and whisker plot here. Yes. So what it ends up happening is I still draw my box from Q1 to Q3. I still draw the line through the median. My lower whisker is the same. The upper whisker now goes to the 33. I do not draw a whisker all the way out to that 55. So this right here is the 33. It doesn't have a name. You could call it the maximum, but the trick is that in a 5-number summary, we don't actually cut that 55 out. Does this make sense to everybody? Let's try another one here. And here we have what amounts to the hardest part of the lesson oftentimes. The numbers are not in order. So we need to make sure that we put them in order without missing any. So help me out here. Let's make sure we don't lose any of them. Once I'm done, you can copy them down. Looks like 2 is my lowest number. What's the next lowest? 11. Do we have a 10? There's a 10. Any other 10s? Here, and actually what I should do, wait a second, I made a mistake. Guys, well, oh no, there was a 2. I was worried I'd use this 2. So 2, and then 10. We have some 11s. 11, 11. Is there a 12? Yeah, there we go. I have a 13 and another 13. If you can manage to line them up with the other ones, you'll be able to tell if you miss any. What's next? 16, 15, 14. There's the 14. 15, 16, 2 17s, 20, and 35. Does this make sense to everybody? They have to be in order. Once they're in order, we can say here is my low number. Here's my high number. Now let's find the middle. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's even. Am I going to have a middle number? If it's even, am I going to have a middle number? Guys, this is actually on the test. They're going to ask you, if there's an even number of numbers, is there going to be a specific middle number, or is it going to be an average? It's going to have to be an average of 2 numbers. So I'm going to come in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 1, 2, 3, 4, 5, 6, 7. Right here. 1, 2, 3, 4, 5, 6, 7. Halfway between 13 and 14. Does that make sense to everybody? Halfway between 13 and 14. Add those together, divide by 2, we get 13.5. Now I'm going to find, this is my bottom half of my data. 1, 2, 3, 4, 5, 6, 7. Okay, that's going to have a middle, right? 1, 2, 3, 4. That 11 right there is Q1. The upper half also has 7. So 1, 2, 3, 4. That 17 is my Q3. Now talk me through it. How do I find the IQR? Q3 minus Q1, which is 17 minus 11. 17 minus 11 is 6. What do I do with that 6? Multiply it by 1.5. 6 times 1.5 is 9. Again, the shortcut, you guys, the shortcut for multiplying by 1.5, I want half again. So if I cut 6 in half, that's 3. 6 plus 3 is 9. 1.5 times. So there we go. There's 9. I'm now going to find my lower and upper boundary by, some years people still get this confused. I'm going from the box, I'm going below the bottom of the box and above the upper end of the box. So that means 11 minus 9. 11 minus 9 is 2. That's my lower boundary. 17 plus 9 is 26. That's my upper boundary. Again, it's from Q1 and down, Q3 and up. Often, I have students that try to use one number for both. They try to go above and below the Q3, or above and below Q1, or above and below the median. It's below Q1 and above Q3, below the box and above the box. Yes. Can you wait till we're done with this problem? If you need to go, that's fine. But if you can wait just a minute, let's make sure we've got this done. Once we've got that, I have all the data. So I need to go from 2 up to 35. So I could probably do 5s again. Let's go with 0, 5, 10, 15, 20, 25, 30, 35. You could do 4s, you could do whatever you want to. Just make it consistent. Every once in a while, I have a student that just draws a box of whisker plots and labels it. That defeats the purpose. We want to see how wide the box is or how long the whisker is. Don't just make it always the same box and whisker and put the numbers on it. That doesn't help. So we need this consistency. Once we've got that, we can label everything. So we're looking at my lower boundary, or sorry, not my lower boundary. My lowest value is at 2. My highest value was at 35. My median was at 13.5. I should probably be labeling this 13.5 because it's kind of in the middle there. You could label all of them. 2, 35. And then I have quartile 1 was 11. Quartile 3 was 17. There's my box. Now, before I go any farther, do I have a point beyond the lower or upper boundary? So my lower boundary was 2. Here's my lower boundary. Is that point okay? It's on the boundary. That's fine. On the boundary is okay. But then up here, my upper boundary is 26. Do I have a point past that? The 35. So that point needs to be X'd out. That point is not a part of my box and whisker plot. It's an outlier. I cross it out. Then I go to the next highest point, 20. That's going to make my whisker. That was a wobbly whisker. Let's try that again. A little better. There's my box and whisker plot. Does that make sense to everybody? We got one more, and then we're done with the notes. Let's do it one more time. Yes, go ahead. So let's put these in order. Put these in order. Looks like lowest, again, help me out here. If I miss one, let me know. Got 1 as the lowest. 5, 8, 10, 12 next. No, we have 2 10s. No, yeah, we do have 2 10s. So 10, 10, then 12, then 13, 16, 19, and 45. So it's perfect. We've got all our values. Here's the low. Here's the high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers. Do I have a middle one? No. So that means 1, 2, 3, 4, 5, right in here. My median is going to be 11. Halfway. Again, is everybody clear how I'm finding these? Add the 2 numbers together, divide by 2. 10 plus 12 divided by 2 equals 11. That's my median. Now I can look at the lower half, right? I don't have the 11 isn't included because it's my median. My lower half, though, has a middle number of 8. 8 is my Q1. Upper half has a middle number of 16. 16 is my Q2, or sorry, Q3. Q3. And really here, I could draw this in right now and then check for the outliers if I wanted to. Or I can get it all set up, find my lower and upper boundary first. Either way is fine. Let's go ahead and draw in what we have so far. So lower, let's see here, we're going 0, 5, 10, 15, 20, 25, 30, 35, 40, 45. So my low value was 1. My quartile 1 was 8. My median was 11. My quartile 3 was 16. And my high was 45. What do you guys think? Is there going to be an outlier here? Probably. So we're looking at this. This is my low value. This is my high value. This is my median. This is Q1. This is Q3. So I know that this is going to be my box right here. You can make it as big or as small as you want as far as its height, but it goes through those numbers. There's my box. The IQR is this distance right here. This is my IQR, the width of my box. So in this case, IQR is 16 minus 8. (16 minus 8). 16 minus 8 is going to equal 8. What do I do with that 8? Turn to the person next to you. Tell them right now, what do you do with that 8? You have no idea how many people forget this. Don't forget, multiply by 1.5. Again, I don't want anybody to miss that. It's real easy, but you have to remember that you multiply by 1.5. So 8 times 1.5. Multiply, use a calculator, that's fine. We get 12. That is what I'm going to add and subtract. If you want to draw that in here, so 16 plus 12. 16 plus 12 is 28. So right in here, 28 is my upper boundary. And then I go down to Q1, 8 minus 12 is -4. My lower boundary is off my graph. So which point is my outlier? Which point's my outlier? The 45. Does that make sense? The point that's way out here. So cross that one off, make it an X. It should be on the graph, but it should be X'd out. And then the 19 I'm going to put on there as my new whisker end. Connect here. There's this whisker. Connect down here. There's that whisker. Does that make sense to everybody? Any questions with what we've done so far? Now everybody's full attention. There's going to be one last thing that shows up on these. If I ask you how much of the data is between 8 and 16, what % are you going to tell me? 50%. Does that make sense? because it's 25 and 25. Each section is 25. If I go from box N to box N, the box always has 50% in it. That's the point of the box. It's the middle half of my data. And that's it for this lesson. We'll probably do a preview of, or we'll start off the second section in just a moment, or the last section in a moment. Yes.
Can I interject here?
Yeah.
When I took math eons ago, I always used to ask myself, why do I care? What's this going to do for me? How is it going to be used? Let's say that Mr. Coons gives the same math test every year. He gives it to 100 people the first year, and the graph shows up like this with 50% between Q1 and Q3. Every year, if he's teaching exactly the same thing in the same way, the data should be the same. 50% of the class should be between Q1 and Q3. If all of a sudden, I don't know, 50% is in the lower quartile, that means that he has not covered the same material in the same way. Something has changed.
That's exactly right. And so you can compare box and whisker plots to each other and say, okay, oh, maybe it's going up each year a little bit because maybe I'm getting to be a better teacher. I'm figuring out what works and what doesn't. And then we have a year like last year and everybody's studying at home, and then it shifts down because we're all struggling to just like do basic stuff. And then we have to start working back up. You can compare year to year. Where is that middle 50%? Is the middle 50 scoring on a test between 70 and 85%? Or are they scoring between 60 and 75%? That's a big difference. And that helps us see, okay, where is the majority or the middle half of the class doing? Kind of the center part, not the people that are at the extremes on the top or the bottom, but the average middle. Does that make sense? As opposed to just a single number, which is the mean or average. The mean or average is just a single middle. That doesn't give me as much information as this. And one more point while we're on there. Is everybody clear that the average, mean, is one way of showing the middle of a data set? The median is another way of showing the middle of a data set. Yes. Yes. All right, you guys, we're doing the homework. Numbers, I believe, 1 through 7. Let's take a look at it real fast. So you're going to be filling in this 5-number summary, putting in the minimum, quartile 1, median, quartile 3, maximum. Solving everything here. All right, number 3 is not in order. Oh, and we're going to talk about 6 and 7. Okay, so here's what we're going to do. I am going to let's all together. One of them didn't take a pass. So if you can wait just a minute. Yes. Oh, actually, no, she's back. Never mind. You can go. So let's put number 3 in order right now, because this is where most people make mistakes, is they don't get these numbers in order. So let's do that just real fast, all together. You know what? No, I'm going to change my mind. Cut out number 3. Just don't do number 3. We'll get enough practice in the other ones. I would rather you guys finish this and feel confident than spend 5 minutes trying to make sure that these are in order. So everything, numbers 1 through 7, skipping number 3 for now. If you want to do number 3 for extra credit, excellent. We will talk about numbers 6 and 7 in a minute, okay?